All right, so these notes are going to look at quadratic equation graphs. And what quadratic equations are, let me grab a different color here, is these are equations that have x squared as the highest degree. So it might look something like y equals x squared plus 3x plus 1. That would be considered a quadratic equation. And what they're always going to look like is they're always going to have the shape of what we call a parabola. A parabola is a graph of a quadratic equation, and it's U-shaped. It's always going to look something like this. This one happens to be upside down. Typically, they're, well, not typically, I mean, you know, some graphs are going to be downward facing like this, so some are going to be upward facing. So let's talk about all the different parts of this parabola. First is what we call the vertex, and so the vertex in this case is 3, 4. Every parabola is going to have a different vertex, but the vertex is where that changes direction. So this graph is going up until it gets to the vertex, and then it starts going down once it gets past the vertex. The x-intercepts are where it crosses the x-axis, so at these 2 points, 1, 0, and 5, 0. These are also called the zeros. Zeros are where it crosses the x-axis or the x-intercepts. You also might hear it called roots as well. So these are really, really important when we talk about quadratic equations. The x-intercepts or the zeros or the roots, however you call it, they're gonna come up over and over and over again. Not just with quadratics, but even higher degree polynomials like an x to the third or an x to the fourth. That's going to be one of those key things, is where does it cross the x-axis. Y-intercept is where it crosses the y-axis, and here it's at 0, -5. And then the axis of symmetry I have in red on the graph, and that is the line that cuts this parabola exactly in half. And so I'm going to get rid of some of this stuff just so that we can see it a little better. But this parabola is perfectly symmetric if you cut it on that red dotted line. And so this is called the axis of symmetry. And that would be, in this case, a vertical line at 3, so we would write x equals 3. Now, for maximum or minimum, this would be a maximum because it's the highest point on that parabola. So this would be considered a maximum. And depending on you know, what textbook and stuff you use, sometimes they'll say the maximum is at 3, 4, so it's the vertex. Sometimes they'll just say y equals 4 because it's the highest value. You're just really looking at the y value. So these are all the key parts that we're going to look at when we talk about graphing quadratic equations. I have 3 examples we're going to talk about in this notes video, and they're all 3 of them are in different forms. So let's start with the first one. The first one is called vertex form. So we're going to do this one by hand, and then we'll use a calculator to help us with the others. So let's first start by making a table of this equation. And what we're going to do, the really important part is, what are we going to pick for our x values? And in particular, what are we going to pick for the middle x value? Now, often what you'll see people do is they'll just go -2, -1, 0, 1, and 2, and then plug those in. But if you do that in this case, you're going to get some numbers that are off the graph. And so let's be smart about what we pick for our x values. And what we're going to do is we're going to pick whatever makes this equal to 0. Here, I'll write it out so that... So, whatever makes that inside the parentheses 0, and that's going to be -3, because -3 plus 3 is 0. So that's going to be what's going to go in the middle of our table, and then we're going to just pick some numbers around there. So -4, -5, -2, and -1. Now, if we plug those in, let's do that. We've got -5 plus 3 squared minus 7. If we plug that in. Negative 5 plus 3 is negative 2. And that would be 4 minus 7, which is negative 3. So then all you do is you just go in and you change this, so it'd be negative 4 plus 3, and that ends up being negative 1. Negative 1 squared is positive 1, and 1 minus 7 is negative 6. And then we plug negative 3 in. Let's see. Yeah, that's going to happen. This becomes 0. 0 squared is 0. 0 minus 7 is negative 7. All right, let's plug negative 2 in. This becomes positive 1 squared, which is 1. Oops. And 1 minus 7 gives me negative 6. And what you'll notice on these is they're very symmetric. That's why we have that axis of symmetry. And so you know that negative 1 is also going to have a y value of negative 3 because this is symmetric on the y's. So our vertex is going to be that middle value, negative 3, negative 7. And that's why this is called vertex form. So it's always the opposite of that number, which in this case it's x plus 3, so the x value is negative 3. And then it's always the same as this number. So since that's minus 7, that's the y value, which is negative 7. So that's where the x and y come from in this equation. The x-intercepts, in this case, we would need to expand this table out a little more. So let's do that. If we put 0 in, 0 minus 3, or 0 plus 3 is 3. 3 squared is 9. 9 minus 7 is 2. So looks like our x-intercepts aren't going to be nice numbers in this case. So we're going to use a graphing calculator to figure those out later. So we'll come back to that in a moment. Same with the y-intercept. Well, the y-intercept is right here. That's when x equals 0. So that's going to be 0, 2. So let's graph what we have so far. Negative 3, negative 7, negative 4, negative 6, negative 5, negative 3, and then negative 2, negative 6, negative 1, negative 3, 0, 2, and then it'll be nice and symmetric, so there'll be a 2 up there. So it's going to look something like this. Okay, so the axis of symmetry is going to be right through that vertex. And that's at x equals negative 3. And then, do we have a maximum or minimum? Well, here we have a minimum. And that minimum is at negative 3, negative 7. Or, like we said, it's just y equals negative 7. Either way you write it is fine. Typically, you'll see it the second way. Okay, well, let's figure out where these x-intercepts are, and we'll probably end up getting an approximate x-intercept, but we'll see. Maybe we'll be able to get a nice decimal. So I'm going to pull up Desmos. There we go. Let's split screen for a little bit here. And let's type that one in. We've got, in parentheses, x plus 3 squared, and then minus 7. All right, so we can zoom in on this. There's our vertex, negative 3, negative 7. And then our x-intercepts are not a nice friendly number. They're going to be some decimals will round. So it's going to be negative 0.354, 0. And then negative 5.646, 0. So those are going to be our x-intercepts. There are ways to solve this algebraically. We'll look at that at a different lesson. But if we're just using the graphing calculator to find those, then that's how we would do that. All right, I'm going to move Desmos out of the way for just a moment here. We'll come back to that in a second, but let's get back and get to our notes here. Okay, so let's look at the next form. This is called standard form. And unlike vertex form, we can't tell where the vertices are or where the vertex is based on the equation. We would have to do some algebra to figure that out. But for now, what we're going to do is we're just going to use the Desmos to figure that out. So let's make a table. And then this time, we're going to let Desmos help us with that table. So let's pull that back up again. And I'm going to type that in. So it's going to be 1 half, 1 divided by 2, and then you just hit the right arrow, x squared minus 4x plus 6. All right, so I've got the equation typed in. There is my vertex at 4, negative 2. And then what I want to do, if that's my vertex, I want to pick a couple around there. So I'm going to do 3 and 2, and then 5 and 6. So here's how we can get a table on Desmos, then this will help us figure out the table, is if you look up above the equation, there's a plus sign, an undo, a redo, a gear, and then 2 arrows. We're going to click on that gear, and we get some stuff that pops up. Well, there's a table here, if you see that table kind of right in the middle, and that's going to give us our values on our table. Now, if you notice, it automatically picks negative 2 to 2, which we don't want. We want to use the ones that we picked. So if you go down to the last one and just hit enter, it'll go 3, 4, 5, 6. And then if you don't like those, you could, type in whatever you want for x. If we wanted 14 for x, you could do that. But we want 2, 3, 4, 5, and 6. So 2 is at 0. 3 is at negative 1.5. 5 is at negative 1.5. And 6 is at 0. So we can start filling some stuff in here. And I don't know that I need Desmos anymore, so I'm going to get that out of the way just so it's not taking up half of our screen. Our vertex is at 4, negative 2. So over 4, down 2. Let's graph the other points. Over 3, down 1.5. Over 2, up 0. Over 5, down 1.5. And over 6, up 0. So our graph is going to look something like this. And so our x-intercepts are going to be 2, 0, and 6, 0. Our y-intercept, I should have looked at this before I got rid of Desmos, so let's pull that back up. Our y-intercept is when x is 0, so that's going to be here at 0, 6. So our y-intercept is at 0, 6. All right, our axis of symmetry is going to be right through the vertex. And so that's going to be at x equals 4. And then this one has a minimum as well. And that minimum is at y equals negative 2. All right, so we looked at vertex form, we looked at standard form, and then our last form is called factored form. And so this looks like where we have two factors next to each other here, x plus 9 and x minus 5. So with this one will give us our x-intercepts. We'll talk about how you get those in just a moment here. But let's pull up Desmos again, and let's plug this in. So I'm going to type in negative x plus 9, and then x plus 5. And let's see, where's my graph? It's way over here. All right, so over here I've got, there's my kind of 3 key points. We've got negative 7, 4 is our vertex. So I can fill that in, x, y, negative 7, 4, negative 7, comma 4. Our x-intercepts are at -9, 0 and -5, 0. And so let's stop there and notice that those came right from the equation. The x plus 9, the one x-intercept is whatever makes that 0. That's why we call that a 0, because it makes the equation equal to 0. So -9 plus 9 is 0, and then 0 times x plus 5 is 0, so that's called a 0. Same thing if you plug in -5, because we have -5 plus 5 in the second factor. So those are called zeros. Those are the really important parts of this equation. The y-intercept, I'd have to follow this graph way down here, and that's at -45. So our y-intercept is at 0, -45. The axis of symmetry is the one that's going to go right through that vertex. So that's going to be, I'll just show you real quick, x equals -7, and we've kind of been saying that that's what it is, but you can see that that cuts it right in half on that at that vertex. So that's going to be x equals -7. And then this one has a maximum value, and it is at y equals 4. Now the only thing we didn't do is we didn't get a table. And so, let's see, we want -7 to be in our table. So I'm just going to go down here and type -7. And then I want a couple around there. So let's do -8. Let's do -9. Let's do -6. And let's do -5. So that should get us a couple on each side of -7. So -6 is 3. -5 is 0. -8 is 3, and -9 is 0. So now I can graph this. I'll get rid of Desmos. I don't need that right now. -5, 0 is right there. -9, 0 is right there. -6, 3. -7, 4. -8, 3. And then we can just graph it. So obviously the y-intercept's going to be way off this graph, so I'm not going to worry about graphing that right now. But there's going to be my parabola. Now, one quick couple things that I want to talk about here. If you notice, this has a maximum, and that's because of the negative out in front. On the others, it was not negative out in front, so we can look at this real quick. This 1/2 was positive, so it was U-shaped like that. The number out in front here, there's no number out in front there, so that's a 1. And that was U-shaped as well because there's not a negative out in front. So whenever you throw a negative out in front, that's going to flip the graph upside down. The other thing I want to talk about is you know, if you look at the difference here, we're going up by 3, up by 1, and then up by 1, and then up by 3. And this pattern is going to continue. So if we go -10, this is going to go up by 5. So that's going to be -10, or sorry, it's going, it'd be -5 because it's going down actually. So I should probably correct that. But the difference is it's changing by 3, it's changing by 1, and it's changing by 5. Then if we extended it out, it would be changing by 7. It's always going up or down by that negative number. So, or excuse me, that odd number. I said that wrong. So, just some patterns here to look for with parabolas. There's a lot of patterns. There's a lot of symmetry. They're really cool equations. So, that is notes for graphing quadratic equations.